Ed, what's going on?
So currently what we're doing is something called conditioning with the accelerator. So we've just come off the back of a maintenance shutdown where we're upgrading some of the components inside the accelerator itself.
Right.
And what that means is that we need to open the main acceleration tube in the accelerator, which is normally at vacuum.
So that's pretty major.
So it's a pretty major...
Open heart surgery.
Something like that, yeah. But I mean, it's something that we do fairly regularly, like once a year. The trouble is, once you open the accelerator itself, you let lots of air into it.
Yep.
And that air contains moisture. And so when you close everything up again, it takes some time to bring the accelerator back to its kind of operating performance.
Okay, so you've closed up again.
Yep.
And we're pumping now?
Yeah, so as soon as we close up, we start pumping, and we're down currently to about 10 to the minus 7 torr. So it's still at quite high vacuum, but what you get in the acceleration column itself is water remaining kind of on the surfaces of different materials.
Right. Okay, so it doesn't come flying straight out with all the air, the oxygen and the nitrogen.
It does, it just happens quite slowly. So water has kind of a nasty habit of sticking to stuff, so it takes a long time to actually pump it out. So what we do is something called conditioning, which means gradually increasing the voltage of the accelerator to try and disturb the water from the surfaces of materials inside the accelerator itself, so that it can then be pumped out.
So when it's running, the accelerator has a voltage on it.
Right.
That's what it's all about, right?
Right, right.
Yeah. That's how much?
So currently, well, the whole accelerator, when it's fully working, we can go up to about 15 million volts.
15 million volts.
Currently, we're running at 5.9 million. So we're only using a certain fraction of the accelerator because we want to concentrate the conditioning on those units.
So you're kind of ramping up, is it kind of heating it, or putting some voltage on it to spray off the water or cook it off?
So it doesn't actually heat it, but having the voltage on will kind of encourage the water to move, and when it moves, hopefully you can pump it out.
Here, have 5 million volts on you to encourage you to move.
Yeah, something like that.
Okay,
please.
Nice.
Yeah.
Please.
But it can take a few weeks, actually.
A few weeks?
To get up to kind of peak performance.
Right, so you just sit here watching that number for 6 weeks?
Not 6 weeks, because we'll get back into operation sooner than that. But basically what we're doing currently is just slowly ramping up the voltage on the accelerator up and down, and that's enough to disturb some of the water to allow it to then be pumped out. And you can see on this scope here, actually, the line on the top is actually coming from X-ray detectors that are in the accelerator itself. And so when you get kind of molecules moving and ionizing stuff, you can get X-rays emitted. So once we get to the point where we're not seeing any X-rays at the top, that's
so there's lots of little oh, there was a bit of a there was a good one.
So there was a good one.
Right.
So that was coming from some event within the acceleration column itself, where something got ionized, there was a kind of small spark, and lots of X-rays get emitted. So what we do is we keep kind of gradually pushing the acceleration voltage up until the X-rays die down, and then we're ready to run again.
Okay. And after that, is there any more steps, or are you good to go?
Pretty much we're good to go then. I mean, it depends on the voltage required by the user. So often we'll do conditioning during runs as well, so that if we want to kind of just push it up to a little bit higher voltage. But
okay, so you don't run everything at maxed out voltage?
No, it depends on the application. So for some of our, so for example, from our some of my studies where we do nuclear reactions, often we don't want the highest energy possible. We want a very specific energy, but it's not necessarily the highest we need, or the highest we can give.
Right.
So it just depends on what experiment you're doing.
Yeah. Okay. So experiments, a couple of weeks, you reckon?
Hopefully we'll be back in a couple of weeks, yeah.
Okay. Thank you.